purpose of this video is to take a look at calculating the spread of data and measuring the spread of data using the range, the sample variance, and the sample standard deviation. So we're going to take a look at a data set, and this data set are the heights of some 3-year-old children from a preschool. We're going to measure the spread of this data starting with the range. So we are going to take the tallest child, which is 42 inches tall, subtract the smallest child, which is 26 inches tall. The range in this data set is 16 inches. That's probably the easiest way to measure spread in terms of calculation. Now, sample variance, things get a little more complicated. They're not too bad. We start off with this chart. Sample variance is very cookbook, and it's once you get the process, it's pretty simple. This x sub I are going to be the actual data points, this column right here. So x is child and I is like a counter, so child number 1 is 26 inches tall. Child number 2 is 31 inches. Child number 3 is 32, 27, 35, and 42. So there is our actual data set listed. Now the sample variance is all about comparing each child to the average or the mean of the data set. So what I have to do is I have to calculate the average or X bar. The average height of this class is 26 plus 31 plus 32, 27 plus 35 plus 42, just the average, divided by the number of children, 1, 2, 3, 4, 5, 6. The average height of the class is 32.2 inches. There's what we have for our average. Now, that 32.2 inches, that average is going in my second column, and I'm just going to write that down 6 times because I'm going to compare each child to that average. That's what this next column is all about. I am going to say the first child compared to the average, I'm going to subtract those two values. And when I do, I come up with negative 6.2. And people get all nervous when they see that negative. What that means is the first child is 6.2 inches below the average. Second child, when I subtract, is 1.2 inches below the average. Next child is 0.2, a little bit shorter when I subtract. Fourth child, below the average. The next child, when I subtract, I get 2.8, and this is positive. That means that that fifth child is above the class average in terms of height, and then the last child is very tall. When I subtract, I get 9.8 inches above the average. My last column, I'm simply going to square this previous column. Negative 6.2 times negative 6.2 is 38.4. Negative 1.2 squared is 1.4. Negative 0.2 squared is 0.04. 27, 7.8, and 96. So there's my column creation for the sample variance. Now, to do the actual calculations, what I'm going to do, I am going to add up this last column. That summation formula from the previous video, we are going to add this last column, come up with 170.64. And what I'm going to do here from the formula is divide by n minus 1. And n is the number of data points. So in this case, what I have is 170.64 divided by 6 minus 1. There's 6 children in the class, 6 data points. Going to divide that by 5, and my sample variance 34.1 inches. So that's a lot of calculations for the sample variance, but like I said, it's very cookbook and it's pretty straightforward. The last thing I'm going to find is the sample standard deviation. That is just the square root of my sample variance is 34.1, and that is 5.8 inches. So there are all three values, the range, sample variance, sample standard deviation for this data set. What standard deviation means is, on average, typical child is 5.8 inches away from that 32.2 inch average for the class height. Could be taller, could be smaller, but that's a pretty significant spread. See by the actual data points that there's a lot of spread in that data. Let's take a look at number 2. Let's say we've interviewed 1, 2, 3, 4, 5, 6, 7, 8 smokers. 1, 2, 3, 4, 5, 6, 7, 8 smokers. And we want to find, again, the range, the variance, and the standard deviation of this data set. Now, the range. Is 0. We interviewed these 8 smokers, and they all smoked 7 cigarettes. The maximum number of cigarettes that they smoke per day is 7. The minimum number of cigarettes they smoke per day is also 7. Max minus min, 7 minus 7 is 0. My sample variance. The average number of cigarettes is 7, and each smoker is 0 cigarettes away from the average. That's also 0. I don't have to calculate anything. That data is tight. There is no spread. And the standard deviation, the typical smoker is 0 cigarettes away from the average. The average is 7. They all smoke 7 cigarettes a day. My standard deviation is also 0. There is how you would do the second example using the range variance and standard deviation spread concept. Let's take a look at a third example here. What we have is 3 different grocery stores. They all sell wine. The average cost of wine is $14.99 in each grocery store. Standard deviation for each grocery store is given. So what we want to do, we want to talk about maybe applying this in a common sense sort of way. Store number 1 would probably be a Walmart, a very general store in terms of their standard deviation being small indicates there's not a lot of variety in their products, not a lot of variety in cost or quality. Everything is pretty tight. Everything is sort of the same. Store number 2, the average bottle of wine is the same as Walmart, but there's a bigger spread in price, probably a bigger spread in quality. This might be a Kroger's or a Giant Food or something like that, where there's more variety and more spread in quality and price. I'm sure you have the pattern now. The store number 3, the average is the same as Kroger's and at Walmart, but the standard deviation is much more, which indicates there's a larger spread in the price, going to be a larger spread in the quality. This would be some specialty store for wine. I don't know, like the wine cellar, where you can get just about any type of wine you want. That standard deviation reflects price, the quality, in comparison to Walmart. That lower standard deviation means there's really not a lot going on in terms of variance, price, and quality. Number 4, if we wanted to figure out the data set with the largest standard deviation, which would it be? The spread in data set A goes from 2 to 12, spread of B from 12 to 22, spread of C from 102 to 112. All 3 of those are sort of tight data sets. 20 to 120, that's a spread out data set, and that would show up with the larger standard deviation. If I were to calculate that, that's where the larger standard deviation would be because there's a bigger spread in data. Now, for question number 5, example number 5, what we want to do, we want to figure out the sample standard deviation if the sample variance is 501.76. So all I have to do is take the square root, and when I do that, I get 22.4. My answer is choice B. So that's what's showing that the standard deviation is the square root of the sample variance. So that was easy. Number 6, the last example we're going to do, we have 2 sets of states and their literacy rates. Top 5, the bottom 4 with the District of Columbia. And we want to figure out which data set has the largest spread or variability in literacy rates, the top 5 or the bottom 5. So what we're looking for is the larger spread in data. This data set goes from 94 to 93, that's pretty tight. This data set goes from 81 to 77, also pretty tight, but not as tight as the first data set. This is where there is more variability in that second set.